Hi, and welcome back to the Mob Mentality Show. I'm Chris Lucian, and my co-host is Austin Chadwick. And today we have Brett Schuchert, and we're going to talk a little bit about legacy code, listening to the code, and things that he looks for when joining a team. So, but before we get into any of that, Brett, can you introduce yourself and talk a little bit about what mobbing is meant for you?
Sure. Hey, well, first of all, Chris, thank you, and also Austin for inviting me on. Really appreciate it. And you've had a few of my colleagues, so it's great to be here. So I've been coding for years and years. I started coding I'll say I started coding in 1985. That's when I started my CS degree. But I had basic in COBOL and assembly by the time I got to college. And so fast forward, I've been doing pairing and or mobbing since the early aughts. I thought I knew what TDD was in the early thousands, and then I started working at Object Mentor with Bob Martin, and then I learned what TDD really was. So I got educated. I also, to mention legacy code, about the time I joined Object Mentor, I happened to come across Working Effectively with Legacy Code by Michael Feathers. I read that book, and as I was reading that book, I went to give a talk at a conference, and Michael Feathers was there, and Bob Martin was there, and I talked to Bob, and that's actually when I joined Object Mentor. So, that got me more into XP and such than I ever had. I was working I'm lucky. I was working at Industrial Logic when Woody was there, and the mobbing stuff, his approach was starting to, take shape, and he kind of went and blossomed into his own thing, which is wonderful. So, I mean, I have managed to rub elbows with a lot of great people. And just as a recent example, since we're talking about mob programming, I recently switched from coaching over to a development role. And on the project, it's React. I've never done React Native. And the first day, I had done a little bit of setup. I had installed some software. We started at 10 o'clock, and by 11:30, I'd pushed to main. Test first. Yeah. So I went from never using React Native. I mean, I had read a little bit of React Native, but I didn't know React. Now, I basically kind of know JavaScript. I understand promises and asynchronous and all that kind of stuff. But in terms of actually using React and Redux, it's a different, it's not that big of a deal, but you got to get in their headspace. And so the mob just did it for me. It was wonderful. I mean, I don't mind coding on my own, and I don't mind it at all, but I really prefer having another person. And the reason I say that is I'm really bad at coming up with requirements, right? Like if you remember the Wii and the Mii's on the Wii where people would make up their own, like yeah. I had one. My wife and daughter had 20 each, and they would change their clothes. So if you asked me for requirements on the Wii, I would have had games and no Mii's. So that's why I like having a second or third or fourth person, because it breaks you out of your ruts. It breaks you out of your assumptions. I mean, if you can let go of your need to have the answer and listen to what's going on, you're going to find better solutions. And I can say from years of teaching that I learned a whole bunch from teaching. But for the grace of God go I, either from consulting or teaching. So I've seen a lot of clever examples of design solutions to familiar problems when I was teaching, which then you generalize and you can use later on. So, nice. Yeah, I mean, mobbing makes it, for me, it's once you get over the ego issue of, my God, people are actually seeing me type. My God, people are actually seeing what I type. Once you get past that, it's wonderful. Yeah. And just to let people know, I felt that as well. My first consulting job was for Smalltalk. And we were using a tool in Smalltalk called Envy. Have either of you heard of Envy? No. Every time you save, it's built-in reversion control with knowledge of the language. Every save is a version, and I didn't want people to see my saves, and so I actually had another instance of Smalltalk. I'd do my coding over there, and then when it was good enough, I'd copy it over here because I was too embarrassed to have people see all my steps. But once I finally realized I don't know everything, and actually I internalized that. Once I gave up on having to have the answers, it makes life a lot easier. Yeah.
Nice.
Well
nice.
said. Well, yeah. Go ahead.
I was just going to say, before we started recording, we were talking about ensembling and mobbing, and I love the phrase you said, not aloning. And so,
not aloning.
Yeah, there you go.
Yeah.
So I think I agree with the benefits you're talking about for sure. And but I guess maybe let's jump into some of the topics you're talking about. So this one, listening to code, really jumped out to me. What are you thinking there?
Okay, so really, when you come to, let's talk in the context of test driven, right? So first of all, I make a distinction between test driven and test first. All right. For me, test driven it's truly experimenting, right? You're making a statement of fact that isn't true. You write a test that it expresses the universe should be this way. The universe is not this way. So you express what you want and then you make it happen. And that's sort of the experimental sort of going through and slowly through time growing your solution. For the only difference with that and test first is, like, for test first, I know I'm using, they say, the shunting yard algorithm. So I go and find the pseudocode for the shunting yard algorithm, and then I instead try to develop a series of tests to build up to the algorithm rather than write all the code and then test all the paths. So one thing is, if you have a predetermined solution, you might not be listening to the code. I'm not suggesting you shouldn't have a predetermined solution, but it's how hard, like you're convinced that it's going to be the command pattern. This is definitely going to be the command pattern. Whatever I'm doing, it's going to be the command pattern. Actually, that's a bad example because it's often the command pattern. But let's say, right? Let's say
the most interesting wrong one.
You're going to use, yeah, there you go. You're going to use Visitor. All right. How do you guys? Are you familiar with Visitor? Are you familiar? I hate Visitor. I absolutely despise it. Here's Visitor is a fine pattern. First of all, none of the patterns are bad, but if you look at Visitor is great in a context where you have two different things and they each have their own hierarchy, and the hierarchies are stable. But if you have either unstable hierarchy, then you got problems because you have exponential growth. And there's a version of Visitor, acyclic Visitor, that makes that better, blah, blah. So notice, you can have all these ideas in your head, but if you force those solutions onto the problem, you're going to have a mess, right? So really, when you're doing something, if you can't get back to green in, say, a few seconds or a few minutes, you're probably not listening to the code. Right now, I know that I'm really giving you symptoms of not listening to code, not actually how do you listen to the code. I'm gonna try to answer that. I mean, I don't have a very good answer, but one answer is the TPP. Oh, go ahead, Chris.
Yeah, I was, what is the definition of listening to the code? Like, wait.
Yeah, and really, it's for me, I'll use Virginia Satir's definition of congruence, which is self, other, and you're balancing self, other, and context. All right, there's me, there's the code, and then there's also the problem I'm trying to do. So the question is, am I trying to put more into it than I need? And if so, is it warranted? And a lot of times you don't know. So since I don't know, if I want, what I'll do instead is I'll try to find a smaller piece that I can verify more quickly. Right? Like, for example, when I'm mobbing with my current group at Industrial Logic, I would say a third of the time or more, the first thing we do is, hey, well, let's try something real quick. We throw it over here, we throw some code in, and we say, well, what does that do? Okay, that gives us an idea. Get checkout dot. Now let's write a test for that. Now, so we're not necessarily test driven in that case. We're sort of test first. But the point is, we gathered as much information as cheaply as we could to figure out what the next step is. So if you're actively trying to figure out what the next step is, you're trying to listen to the code. If you're successful, then you're not going to find that you overdo too much. If you're unsuccessful, you learn from that and try to do less next time. Good example. Are you guys friends? Are you fans of inheritance? Yeah, exactly. No, so why are you on inheritance? If inheritance is the right solution, it's great. But if inheritance is added to remove a few lines of duplication, it's abysmal. Yeah. A good example, the Pink operating system was an effort between IBM and Microsoft to develop a new operating system. And I worked with a guy named Felix Laura, who was on that project, and then he joined my other company. And he told me about a time when Microsoft was sent a bill by IBM for net negative productivity because someone had taken a huge method and rewritten it to a much shorter method. Yeah. So, but there was an example in the hierarchy of a button object. And that button object had 22 levels of inheritance to get to the base object. So wait, you had never heard of the Pink operating system? Wait, why 22 levels of inheritance for a button? And you haven't heard of the operating system?
Yeah.
So it's like a lot of things. The design patterns for the right solution are great. State is a good example of that, right? If you have a problem that is state dependent, and also you have more than just one thing that varies based on the state, it's a great problem. But otherwise, you're adding a base class or a base interface, several subclasses. So the thing to remember, any solution, this is Weinberg, every solution introduces a problem. Every solution introduces a new problem. Hopefully the new problem is less than the old problem. So if you're not getting more information or you're not solving part of the problem, then you're not listening to the code.
Yeah. All right.
Yeah.
But another part about listening to the code is being okay with less. So for me, when I read Refactoring by Martin Fowler, and then this also happened with Working Effectively with Legacy Code, those two books gave me permission to change my definition of good. And what I mean by that is if you look at refactoring, let's say replace switch with polymorphism. It's like 17 steps or so. And when I show that to people, they're like, why the hell would you do all that? I can do this much faster than 17 steps. But here's the essential thing. We cannot stop people from interrupting us. So all we can do is change our work to be interruptible, right? So I'm on step 7, I'm green. Someone interrupts me. I push it. Who cares? It's clean. And someone might say, yeah, but the design's not ugly. Or the design's ugly, but it's like, well, have you looked at the rest of the code? I mean, when do you have something that's not inconsistent and so on? So we apply these metrics of goodness out of context. And so any design principle that only makes sense for Greenfield, throw it out. Utterly useless. Don't care about it. Yeah. Right. So if you have something that only works in one context, that's fine, but it's not a very good thing to work with. So take small steps, no matter, and GPaw Hill does as well. Smaller. Even smaller still, you're still not there, right? Really small steps. Like today, I think I've done 5 or 6 commits to main in the mob I was with, and it's 2:30 my time. So, and commits to main mean all the tests pass, no regression, merged, etc. The usual. We're doing trunk-based development for the most part.
Nice. Yeah, and what's funny about that? I'll interject here with a little bit of sharing on the small commits thing, because recent experience is our mob. Have you heard of Arlo Belshy's Git commit notation?
Yeah. I know Arlo, actually. He worked at Industrial Logic as well. Yeah.
Awesome. Right on. And so we've been using it for a while, and then we looked at the repo for it recently, and we realized that it's been updated to make to fit, like, to do the Git notation for a commit that's like in the good, like the better status, not the risky status. It has to be less than like 6 lines of code. And we're like, whoa, and so there's times where we're unable to follow, but this past week we've been trying to follow it. Like, okay, well, how could we, we do something and it's like 15 lines. And like, well, how could we have done it where it was a 3-liner and then a 4-liner and then a 3-liner, kind of thing. And it's been a good exercise for us in I
think it's a great exercise, right? Because it's forcing you to try something different. It forces you to think about it differently. And even if you don't end up going with the ideal 6, whatever that ideal is, if you come up with a new way of thinking about things, it's wonderful. Right. And I don't know about y'all, but I don't work without constraints, right? My brain is just like, you got to give me something I can lock down so I can make decisions about something else, right? So I cannot be creative without constraints. But that's why one of my subjects was working effectively with legacy code. I mean, you give me a language that has some basic OO capabilities, or it could be a functional language, whatever. But if I have the ability to somehow switch stuff out in a nice way for test doubles, if the language supports that, then it's enjoyable. It's fun.
Nice.
Right? And recently, in fact, talking about listening to the code, I was working in a part of the code base that I didn't understand. This was a couple of weeks ago. And so I was like, well, I don't exactly understand all the necessary setup. So I just wrote, I started doing effectively a characterization test against it. I literally did new, blah, and I ran until I got a undefined exception. And then I said, okay, what's the minimum I need to do to get that to pass? So this is an example of how you can literally let the code talk to you. You call a function, you call a constructor, whatever, and you let it fail. And then you do the least amount necessary to get to the next line of code. And the next line of code. And then when it's done, you have a characterization test. Now, the question then you might ask yourself is this done? Probably not, but it's got me started. And I bet you I've learned a whole bunch about what maybe to do next. So a lot of times you can just treat something like a black box, construct an instance in a test, and start playing with it. And even if you end up throwing that away, what you've learned will then inform your decisions. Maybe that's how you could figure out, like, this is going to be a 15-line commit because I can't figure it out smaller. So try something. Throw it away, try something again, throw it away, or do it and then learn. I mean, because when we do katas, that's really what we're doing. I mean, you do a kata the first time and it's like, okay, you do it the second time, third time. you do it enough so that then you can make variants and understand that this thing that I decided to try is exactly this much different from how I'm used to it. And I stumbled across katas from teaching. I've done some version of Monopoly over 1,000 times easily. Not a full implementation, but design. Same thing with an RPN calculator, probably 500-600 times. I've typed it. I've actually typed it in C, C++, Ruby. There's probably 15 different languages I've done it in. And so anytime I take that problem to a new space, I understand the problem and understand how that problem has been solved in these languages. So if I change the language to, say, a functional language from a non-functional or from a OO language, and I re-implement it, then I'm seeing how the change of the languages affects how I solve the problem. So one of the advantages of having problems that are like ones you're really familiar with is you then use those to learn new things, right? You take something that's somewhat familiar, applying it to a new environment and see how it varies.
Yeah. Yeah. And so with that process, so with listening to the code and interacting with legacy code, I guess, do you look for this in a mob as like a general thing, or is this something just internal to you, or do you externalize that, as you're moving forward? Is there any way that you get that to the rest of the team as you go?
So ad hocly, absolutely. I'm a big extrovert, as you can probably, I don't know if you can tell, but I am. So one, that, and also I'm a somewhat strong personality. So for me, my challenge is not to talk and not to be overbearing, which I can do both of those in abundance. But I've lost my train of thought. I apologize. If I use a technique and the person does not seem familiar, actually, let me be specific. Drew was with me. Drew was not someone that has, and he's a colleague of mine. He works at Industrial Logic as well. And so since I asked Drew, so let's just try something. I'm going to do a characterization test. And I said, well, this is what we're going to do. And then we just did it. So I will say that since I've been coaching for years, I will externalize what I'm doing anyway. I just do it unless people tell me to shut up. So that's a natural thing that I do. But just repeating it, just as I mentioned, when you're describing it to somebody else, you're using a different part of your brain. And so you're actually forming different neural connections and you're memorizing things better. That's, by the way, that's there's a couple things that mobbing does that you may not even understand. And one of those is you're using different parts of your brain. Like you're familiar with rubber ducking, both of you, I assume, right? Rubber ducking, you actually talk to a rubber duck. Yeah. Like how many times you go talk to somebody and while you're talking through, it's like, oh, I just figured out the problem. Well, two things. One, you stood up, which means more blood's going to your brain. You've changed your context by physically moving. So you're actually changing your context. If you're in a rut, literally, if you're in a rut, move your chair, stand up, sit down, take a short walk. But by using your voice by actually verbalizing something, they've done functional MRI scans. It's using a different part of the brain. So you're now using more of your brain, and guess what? You're gonna get more out of it. And here's another little thing: if someone's saying something important, breathe into your nose and into your stomach. It activates your amygdala and your emotional centers, and so you're more likely to interpret what you're about to hear as important.
Oh, interesting.
Right. There's a lot
of there's a whole bunch,
yeah, there's a whole bunch of neurological science behind what we're doing. And I just heard this. So typically if I'm going to give you some numbers, and the numbers are probably wrong, but they're for demonstration purposes. So at any given point, there's like 400 billion pieces of data that you could be taking in. We're taking in around 2,000. So first of all, from a perception standpoint, we get about 0% of what actually is going on. You can, through working with a group, actually go into sort of a flow state. When you're in a flow state, you actually start to take in more information because it suppresses the fault mode network, blah, blah. Again, there's neurology. So when you're actually mobbing in a group, like physically together, and you start to get into a group flow, you start to take in more information, you start to notice more, and you actually are forming, I'll just say this, the Navy SEALs spend more money on teaching people group consciousness than on teaching them how to fight. Wow. And Hell Week is about, can you sacrifice your individual ego to the goal of the team. And how do you do that? Through training, so that you can put yourself into an altered state of reality where you're taking in more information than you normally would and working with other people more fluently. Sounds pretty freaking amazing to me, doesn't it? And that actually is happening in mobbing. I don't know how. I mean, there's more information to be had. It's not as easy over this kind of communication, but it's still better than not mobbing. I mean, me working alone at home versus me working in a pair of mobbing, it's orders of magnitude better.
Yeah.
Right.
Nice.
So yeah, and you can tell this is in the last few years I've been into this kind of a headspace, like the neurology behind the brain and all that kind of stuff and what's going on. And it's making me appreciate a lot of the stuff that people have said or that I've intuitively sort of guessed on my own.
Nice.
So
nice. No, I love it. And that's super fascinating. And yeah, that's something, the neurology of it all is something I've been learning more about. And yeah, we actually have an upcoming guest to talk more about that too as well. But one thing that jumped out to me about what you said there was, so when I saw the topic listening to the code, the first thing I thought about is reading code, and my mind stuck there. And then the more I heard you talking about running experiments, doing tests, talking or asking the mob, so I guess. Do all those things count as listening to the code? Or I mean, like, I guess
notice I didn't.
Avenues.
I'm gonna claim like I said it in a way that was brilliant, but it was lucky. All right, I could have said read the code, but actually I do phrase it as listening to the code. And really what I'm saying there is, I don't care. I am not trying to project my interpretation onto it. I'm trying to understand what it is, right? Because it's and this is just like philosophically, it's a lot easier to make a change if you have a better sense of what is. But if you're denying what is, like you're saying, well, like this should have been this pattern. Well, great, it should have been that pattern, but it's not that pattern, and that's not the code you're dealing with. You have to deal with the code that you're dealing with, right? And if you're in your head and thinking about what it should be, then you're not listening to the code, you're listening to your head. So really, it's all about where is the knowledge, and make sure that you're going to the source of knowledge, and don't assume that you're the source of knowledge. You might be, but then, on the flip side, let's say you are the source of knowledge. If you have a person who's a specialist, fire that person, or no hands on keyboard, right? No hands on keyboard. That's what you do. When you have an expert, you have that expert play a consulting role, and then they're not driving, they're navigating. And guess what? For them, they're now verbalizing something they probably, especially if they're a specialist, they've probably been mostly in their head. It's going to make them better as well. Of course, some people don't want to have the experience, and I completely understand it. I mean, mobbing can be forceful, right? Because I can try to force an approach on you, and I can tell you that there have been times on my current engagement where I had to not mob. An early example was we were doing some native stuff, and we were all like, it was just a black box. We had no idea. So try this, and it got to the point where I was like, okay, I have a superficial knowledge. In general, if I'm doing something, eventually I go a level deeper. Like I've written bytecode for the JVM, not because I thought that's a smart idea, but so that I understand it, so that when I'm thinking about the JVM, I understand what the JVM does, and I understand Java, right? I mean, same thing with, C++ is just compiled C at its heart. So if you understand C, you understand C++, and therefore you understand Ruby, because Ruby's written on top of it, et cetera, right? So you can build up through a chain of reasoning how things all connect together. Did I get to the answer to the question? I think I as often I went far in a field. But listening to the code, we're talking about listening to things, right? And I would argue that you cannot be listening to code if you're not executing it.
Yeah.
Right.
So I have two thoughts. One was the expert not having hands on keyboard. I kind of refer to that almost as chaos engineering for the teams, right? So like if that so what I like to do is I often recommend if somebody has become an expert on the team and maybe some people are struggling to keep up, is just to remove that person from the team and still have them available for questions. Because if they won the lottery and left the company, then they're much less available than if they're just on another team now. So I like encouraging chaos engineering for teams to prove resiliency of the team and knowledge that way. And the other thought I had for listening to the code, I think you talk about like executing the code, and I think it's really important. I also encounter a lot of people that have a lot of difficulty reading code, especially newer, so if somebody's fresh out of college and they've had a kind of a traditional education, they've only ever written code for their projects and read very small bits of code. But the fact of the matter is that most of those people are going to get hired onto a company and immediately be put on a 10-year-old code base that is way bigger and something that they're swimming in. So like one thing I like to recommend to people is the URL is codereading.club. And it's a kata just for code reading, and it's like spend 5 minutes and print out the code, spend 5 minutes and just with a highlighter highlight all the function declarations, and then do arrows pointing to the executions. And what I really like about this exercise is it's that, and then you talk as a group about first impressions, like what's the first thing you notice, what's the second thing you notice, and it helps a lot with like that initial I guess what's going on moment. And I don't think a lot of people get a lot of training in that. They almost get it through osmosis over many years in the industry. So those
are great observations. No, those are great observations. I love that idea.
Yeah.
And a counter, or not a counter, but a complement to that is when I advise people on, like, people will ask me how to learn, and honestly, it's really difficult for me to tell because I learned before Google. When I started using C++, there were no books on C++. I had the source code for the compiler. And then Bjorn Strusup's C++ annotated reference manual. I remember going to the bookstore and seeing it was going to be published in 3 months, right? So before Google, if I wanted to read a book, I would do it all the time. And I had the time because the expectations to learn were so much slower. Now afterwards, deep learning is for people is difficult, but you still need to do it. So, so back to, I didn't finish the story. I could not concentrate in the mob, and the thing is, I had such a black box or lack of knowledge. So what I said was, I'm gonna go and work on a tutorial. I went and worked on a tutorial. I set up a basic project with React Native that was with some native stuff. I got it basically working, and then I brought that back to the group the next day, and then we started making variations on that. And actually, one of my colleagues, friend Mike Reeser, who also works for Industrial Logic, he has a good saying: don't debug a large program.
Yeah.
Right. So we made a small program, and then and what we were doing was a secondary display on an Android device. And we ended up with a solution that was like 5 lines of code. Right. I mean, it was really simple. We started processing the back end, and the front end, we have 2 top-level apps, and it just works. I mean, it's actually, we inadvertently came across a general solution for end screens ignoring performance issues. So, and again, like, the most complicated thing was we have a function that starts a thread in the native code, and then everything else is React Native. So it's like, but at the beginning, none of us knew what it was going to look like. So it's like, if you look at the lines of code to actually do what we did, it's embarrassingly small, but it took us 3 weeks over time to figure it out. So that was a case where my brain had too much of a lack of knowledge, and all of us had too much of a lack of knowledge. So someone had to get enough of a foundation to work from. And so, I'm not 100% pairing or mobbing, though I prefer, my default is to prefer to work not alone. And then in a situation, I'll pick working alone. But I can tell you, I'm old enough that I used to be an architect at a company. I had an office and so on, but that office quickly became the meeting room because we didn't have enough meeting rooms. Right.
Cool.
So even though I had that title and that role, it's like, well, I mean, whatever.
Yep. Yeah. Yeah. I totally hear that. And flowing in and out of mobbing is something I'll do quite a bit as well. Like, especially when you're talking about a problem you're talking about, we're all struggling to figure out the problem, how to solve the problem that we're facing the mob. I notice a lot more experimentation happens on people's own devices, and whether they leave the mob or not, but a lot of independent experimentation happens. And what your experience you just shared, we recently had that in our mob as well, where we were trying to solve a problem, and there were wildly different solutions to the same problem. And some of them were like, I kid you not, like 50 times more complicated. And then so I think there's a lot of value to rapid experimentation and sharing of the results of those experiments, because what we landed with the solution that was like what you said, it was 5 lines of code and 1 piece of technical architecture, and there were people writing 50-page blogs that involved 3 or 4 different pieces of architecture to accomplish the same thing. And so it's it's phenomenal what you can discover and how the simple solution can be so nice. Way less to hold on
and
to.
Also, a solution, regardless of whether it's simple or not,
it
does a couple things. It reduces the net increase in value if you change it at all. Not to suggest you shouldn't change it, but having something concrete, it's a lot harder to argue about how my idea, which is 50 more classes and all that, or 50 times more complex, is better when you've got something that works. You know what I mean? It's
right.
Yeah, and so it really working code really kind of puts a bit of a damper on ivory tower argumentation. Though, as a counter to that, we have something in our current code that just bugs the heck out of me. All right, it's simple. We have a little number pad, and it says discount amount, and it has a negative on the amount. I'm like, a negative discount is you're adding an amount. It's like, and I just can't let go of it. But luckily, we're not dealing. So it's like, I can obsess on that one detail, even though it's utterly irrelevant. And seriously, it's I know the line of code where we're adding the dash, so it's like it's nothing to do. But I'm like, I can't. This really bugs the heck out of me, right? So I just need to get away from that piece of code.
Sometimes,
and actually, I say that jokingly, but there are some times you might see things that actually, I'll use the word trigger in the specific way. It's like when I'm using trigger in the sense that you're experiencing emotion to the point where the part of you that is able to observe yourself experiencing the emotion is shut down. So basically, you are in that emotion. In yoga, we would say something like, you either have an emotion or you are an emotion. You don't want to be an emotion. You want to experience an emotion, and you want to understand that you're experiencing the emotion. So I can actually rationally, I can look at myself getting frustrated with a dash and realize it's not that important. Yes, you're frustrated. Great. I'm frustrated. Cool. But it's not like the frustration is taking me over. You know what I mean?
Yeah.
So, if your internal observer or your watcher or your Atman is present, then you're probably not in too much trouble. But as soon as not, you're definitely not reading the code, right? You're definitely not in the moment. You're definitely somewhere else. And if you're somewhere else and you're not in the moment, if you're not congruent, if you're not balancing self, other, context, then I don't know what you're doing, but it's not effective. It's not effective communication. It's not effective coding. It's, there's some kind of forcefulness to it. Right. So.
Yeah, for sure. Well, we are coming somewhat close to time, but maybe we can get your, before we close, your soundbite on what are the things you first look for when you join a team? Yeah. What do you? Yeah.
Sure. I'll say there's only one book you need to read, and it's The Principles of Product Development Flow by Donald Reinerson, I hope. And actually, we did a book review on that, and John Reed, was it John? I think John posted something on Twitter, and he showed up for our book club twice. And it was amazing. Cool. It was amazing having him there. But anyway, in that book, so that book is, it has, like, let's say it's 14 chapters, 12 chapters, I don't remember. Each chapter is a subject, and from that, he draws a series of principles that might help you in situations. Talks about queuing theory, blah, blah, blah. But you could actually say that it summarizes lean, agile, safe, all of the above, depending on how you decide to use the principles. But there are 3 things that come up all the time. And the 3 things are whip. How much are you doing? And generally speaking, less whip will give you faster throughput. Generally, that's not always the case. How big are you working on things? Batch size. Like, are you doing 1 commit a week? Because if you're doing less than a commit a day, you're not doing continuous integration by definition, by anyone's definition of continuous integration. So how big are you working? Batch size. How much are you working on? And handoff. Queues or handoff. Like, do I have to wait for that person to do things? And generally speaking, reducing all 3 of those will tend to increase your throughput. But really, it's all about what's the things we can do to get the feedback faster, because 99 times out of 100, it's about information or lack of information. And so anything you can do to increase feedback is gonna speed it up. So if I go to a group and we've got, let's say we've got 10 people and we've got 5 things in flight we're pairing, maybe okay. Like, I guess we're pairing 5 things in flight. If you've got 10 things in flight and you've got 10 people and you claim to be pairing, I'm not sure what you're doing. And so I've got some basic formulas for that. But if you look at the actual inputs into those things, it's not like a linear graph. There's a bit of a curve. And generally speaking, it's sharp at the ends and more flat in the middle. So like if your whip is N, if you can get to N divided by 2, you'll probably notice a drastic improvement, but you won't notice the same drastic improvement if you divide it by 2 again, right? So it's just, those are the kinds of shapes. So reduce how much you're doing. Really, it's stop starting, start finishing. Ready? Stop starting, start finishing. So how do you do that? Work on smaller things, get feedback sooner, integrate more often, and have the people available so that you can get stuff done. That's so you just look at those three things, and then you manipulate those 3 things. And sometimes the first thing you do is you don't change them. The first thing you do is, most of the times people don't even know what they are. So how many things are you working on right now? Visualize it. Write out a Kanban. Visualize. How many things you're working on? How long do they take? Track that. Like, is it taking on an average 3 days? Is it taking, here's the thing, is it taking 1 to 3 days? Great. Is it taking 1 day sometimes, 4 months sometimes? Not great. So that can give you some indication of maybe, are you slicing things nicely? You know, those kinds of things. So whip, batch size, handoff. Those are the things.
Nice.
Cues and handoff, really, same thing. And anytime you introduce a cue, anytime you introduce a buffer, you increase the cycle time.
Yeah.
But it might be the right thing to do. I'm not suggesting you don't, right? Really, it gets down to, are you doing it because that's how you do it, or are you doing it because it makes sense? And even if you do the wrong thing, if your intention is good, then it's not the wrong thing, right? Mm-hmm. So for example, I'm going to tie it back to refactoring. The wrong thing is taking 17 steps that are each stable that I can check in whenever I want, because I can just do it in half the time as long as I'm not interrupted, right? So it seems like what I'm doing is wrong because I'm taking too many steps, but I'm not taking too many steps. I'm working in a way where I am more back to a point of stability, so that when I get interrupted, it doesn't matter. I lose my context. It takes me 15 minutes to get back that context. Well, that's fine. I'm green. Who cares?
Yeah.
Right. So anything you can do to make it so that you can work in a way that where you're more interruptible is going to probably improve your ability to listen to things. It's going to allow.
Yeah, that's what's funny, but working to live to be more interruptible, it sounds terrible, but I've actually I learned it. I think I learned it from working on code, kind of from the lean thinking that you're talking about. But I've actually applied it to so many things in life that, because I don't know if with little kids, they tend to interrupt you all the time. And so when I'm working around the house, I'll be walking around with a sticky or something, so that if I'm interrupted, it's okay, because I can just be like, oh, I can pick up where I left off, or whatever. And
yeah, exactly.
Like I try to do everything around the house such that if I'm interrupted, it's okay. I'm not leaving, like, I don't know, the sink running or something terrible or whatever.
Nails on the ground or whatever. Yeah, no, exactly.
Yeah. So
and by the way, and so that just I know we're maybe going a little bit long, but that's an example of transaction costs, right? How expensive is it for you to make it safe to stop, and how expensive is it for you to pick it back up again? And that would feed into how big of the thing you're working on, how much time you need, and so on. So the reason that graphs have a bit of a curve into it, it's a combination of a number of things. But generally speaking, I mean, I can't, I'm not going to bring up a graphic for you, but it's generally sharp at the ends and flat more in the bottom, with tendency being towards the left side of the graph for all 3 of those numbers. Nice. So step 1, if you're not measuring them, measure them, see what they are. And then maybe step 2, see if you can start manipulating them. And by the way, do a small experiment, see what happens. Don't make a big sweeping change. Don't come in and drop in safe or scrum when you're not doing anything, and then just see what the change is, because you have no idea, other than the Hawthorne effect. We change things, maybe the effect, maybe we're more effective, maybe we're less effective. So, feedback, you can't respond to feedback if the feedback is on 20 things. Like, hey, let's do a pull request with 15 files and 150 line changes. That's unless you're going line by line and reviewing with the person that did it, which is going to take about as much time as if you had just done it together. So yeah, on a soapbox, pull requests are for most software development that I work on. Pull requests are an utter waste of time, and they give you more defects and less quality. And I'll throw up, and by the way, all code freezes are examples of buffers or delays. Code freezes, I'm saying this in this very specific way. Code freezes are the cause of defects.
Ah,
And the reason I say that is you freeze the code, you think it's going to be okay. The code never gets frozen, but you do introduce a delay before you continue working on things, or you work on a branch because you've got a code freeze. The longer you diverge, the more likely you're going to have real conflicts, and also the more subtle they're going to be. Right. Nice. So I'm going to stand on a soapbox and say code freezes cause defects. There you go.
Wow. Nice.
How's that for a closing statement?
That's a good closing statement.
Closing statement.
And speaking of closing statements, we are at time. So any other closing statements or anything you want to share or plug before we close it out?
Well, I work in Industrial Logic. We're here to help you make better software sooner. So coaching and implementation. I'm a dork. I'm not much of a salesperson. So yeah. But I would say here's a closing statement. If you can learn to feel in your body where you tend to resist things, like do you catch it in your stomach and so on, if you start to observe that, and then you occasionally go through that, you're going to find huge changes in your life. So if you find, I'm not going to do it that way, I can't possibly work with that person. All right. I don't know why you can't work with that. And by the way, if it's because that person is someone that you can't work with because they've abused you or something, I'm not saying like that. If you're just resisting without any kind of information, then maybe you don't work with that person, but ask yourself, what is it that's causing me to hesitate? What is it that's blocking me from doing that? Because when you go through instead of away, that's when progress happens. And that's general advice for a lot of situations. The path is through, not away, not up, not down, through. So go to your fears. But pick the small fears first, because, once you start doing that, it gets easier. So, nothing too frightful.
Nice. No, I've definitely observed that. And wow, thank you so much for sharing today. We've I've definitely learned a lot. This is a very inspiring conversation. To our audience, if you yourself, or people who are working with legacy code, trying to learn how to listen to the code, and looking for things to look for when you join a team to help them take their next step towards improvement, for working through a problem instead of away from it, and helping them get that progress. Please share this with them. Please like and subscribe, and reach out to us on YouTube, Twitter, and LinkedIn, and more. And thanks again, Brett. We really appreciate you being on the show today. And mob on, everyone, and have a good one. Talk to you later. Bye.
Bye, everybody.
Bye, everybody.